Good morning, dear students. Today we have come with a new video of class 10 on refraction. In the previous class, we have discussed about refraction, how it occurs, and how the refractive index changes from one medium to another medium. Today we have to discuss about a refracting medium, that is prism. Hope you have learned about prism in class 8 only. So here we will discuss little about the introduction, and mostly we will discuss what is happened with the prism and what we want to find out from it. Okay, so what is prism? We all know it is a transparent and refracting medium. So transparent, you all know, through which the light can able to pass. Refracting medium means when the light passes through it, the refraction occurs here. Okay, so the basic principle occurs inside the prism, that is refraction. That's why it is a refracting medium. Now the question has come, how does it form? It is formed by five planes. Five planes. Okay. So in between these five planes, three are rectangular and two are triangular. So it seems to be looking like this. So this type of thing. Okay. So here, if you're not able to understand, so I can able to show it like here. So just like a roof of a heart. Okay, it seems to be looking like this, and here another surface. Okay, so if you see 1, 2, and at back there are 3 rectangular surface and 4, 5 this triangular surface. I have made a model here to show you how the prism looks. It looks like this. So it is the first rectangular surface, if you mention here. Okay, uh, let's do it. Assume it is surface number 1. This is surface number 2. See, it is a rectangular surface, and at back it is surface number 3. This is the triangular surface, surface number 4, and that is another triangular surface, that is surface number 5. So this is the shape of a prism. Okay, so in between these shapes, the two planes are transparent. So that is 1 and 2. That is two rectangular planes. These are transparent surface, and rest of the 4, 5 and 3. So 3 is at bottom, that is also a non-transparent surface. 5 and 4, these triangular surfaces are also non-transparent surface. So here 1 and 2, that is the two rectangular surface. These two rectangular surface are acting as a transparent medium. Rest of the surface, we can say these are opaque, so no light can able to pass through it. So if we have taken the light enters from the surface 1 and goes to the surface 2. Okay, that is the way by which a prism works. Okay, so if I mention here, surface 1 and 2 are transparent, and surface 3, 4 and 5 are non-transparent. And how the light passes? Now if I have seen the model, this is the surface 1 and this is the surface 2. So light enters from surface 1 and move away from surface 2. But when I have hold it in front of you, we can able to see the surface 4 only. We cannot able to see that behind the surface 4 the surface 1 and 2 is there. So that's why when we represent the ray diagram of prism, we have drawn a triangle. Why? Because if I keep it here, you see, we can able to see the triangle. We cannot able to see the whole shape. What is the reason behind that? The reason is that our eye can able to see two dimensionally. Okay, we can able to feel three-dimensional object. So when I hold it, I can feel it. But whenever I have seen in front, we have seen that is a triangle only. We cannot able to understand there is a long surface where the rectangular transparent surfaces are there. And that's why we assume that the light ray incident on this surface and moves from this surface. Why? What is the reason behind that? The reason is that actually the light ray incident on surface 1 and moves from surface 2, but as we can able to see the only triangular surface, we assume that the light ray is incidenting on one side of the triangle 4 and moves to another side of the triangle 4. So that is the way by which we can able to represent the light ray through prism. So that is our next target, to represent the path of light ray through a prism. Let's see. Next one, path of light ray through prism. See, this one also you have learned in class 8, though we will repeat it here again. Okay, so here I have already told, whenever we have to told about the prism we will assume that it is a triangular shape. Why? What is the reason? The simple thing is, when we have seen the prism in front of it, we can able to see only the triangular surface. Rest of the surface is at its back. Okay. So it is clear, this one, that should be the rectangular surface, that is the first surface. This is the second surface. This is third, fourth, and at back it is 5. Okay. So let's give the name A, B, C. Okay. Assume a light ray is incidenting on this path. Okay. Now, in which surface it incidents? AB surface. So we have to draw a normal on AB surface to find the incident angle. Okay, so this is the normal on incident surface AB. So this is the angle of incidence I. Okay, so clearly when the light ray just incident on AB surface, then it try to enters from rarer medium to denser medium, because generally prism is made by glass and outside it is air, so it is rarer, and we have entered to the denser, so the light ray will bend towards the normal. Okay, so after bending it will move in a straight path, because the whole path is its same denser medium, so optical density is not changed, it is same, so it will move in a straight line. So that is your angle of refraction. We will denote it by R1. When it incidents on the another surface AC, clear? So here, to find out the angle of incidence, we have to draw a normal again on the surface AC. So these are the normal, whatever we have drawn. Okay, and name the normal, it is N2. And when the light incidence here, then that one we have to denote it by R2. Now you might be asking, sir, it is the second angle of incidence, so it can be I1 or I2, something else. See, as it is inside the prism, so one angle we have denoted by R1 and another angle we will take it as R2. Okay, so the name should be same, like, that's why. So it is denser and it is coming outside to the rarer medium, so it will move away from the normal. So that will be the path, and this angle with the normal, that is known as angle of emergent, that is denoted by E. Okay, that is angle of emergent. Now here one thing we have to find out, that is, if there is no prism in front of the light ray, so let's name it first. It is P, it is Q, it is R, it is S. So this P, Q, R, S, it is the path of the light ray through prism, and where the two normals meet, let give it a name M. Okay, now the question is that if there is no prism in front of the path of the light ray PQ, then the light ray should travel in this path in a straight line. In a simple straight line the light ray should go, but due to the presence of the prism, the light ray change its path and gone to RS. So if I exceed RS, so they will meet here. So that point we will given a name, that is M dash. Okay, and here we have seen an angle is formed. Okay, so that angle shows the exact path of the light ray, what should be, and the second one, what is the path ray occurred due to the presence of prism. So the path of the light ray is bent by this angle. That angle is known as delta, that is angle of deviation. So deviate means, you all know, if anyone deviates from its own path, own idea, that is deviation. So that is the exact path where the light should go if there is no prism, but due to the presence of the prism, the light ray bends. Okay, so that is the angle of deviation for prism. Now if you see in your book, there is a relation that is proved between angle of deviation, angle of incidence, and angle of refraction. That derivation, it is not important because it will not in your syllabus. I am telling you one thing, any proof on light, it is not in your syllabus, that is the syllabus of class 10. But here we will derive it for your knowledge only. It is not in your syllabus, I am telling again and again. So don't be panic if you don't understand, but I have just show it here because of your knowledge only, nothing else. See, if this angle is I, okay, this angle PQN1, we can write angle PQN1, that is angle I. So angle MQM dash means I am talking about this angle. Okay, you see, angle MQM dash, that should be equals to angle PQN1. Why? Because you see there is a opposite angle or vertically opposite angle. So we can give a name here, and that name should be angle I. Angle M or M dash, that is also I. So if angle MQ M dash, that is I, then this angle, if I have given a name, that is angle MQR, you see, M dash, M dash QR. So this angle should be angle I minus angle R1, because this angle is R1, here it is mentioned. So this portion, it will be angle I minus R1. Similarly, angle, you see, M dash RQ, M dash RQ. I just want to find this angle. Okay, so m dash r q, here you see this is angle E, that means this one also angle E, and here R2 is there, so that should be E minus R2, just like the previous thing. Angle E means SR into, that should be angle M dash RM. Why? Because these are vertically opposite angle. And if I want to find M dash RQ, so this angle, that should be angle E minus angle R2. Now, if I have taken one prism, that prism is prism M dash QR, M dash QR. If this prism we have taken, so you see this delta, it is the outside angle of the prism, and we know for a prism the outside angle will be equal to the sum of inside angle. Okay, so the outside angle equal to sum of inside angles. So M, from triangle MQR, we can say that angle delta, that should be equal to angle M dash QR plus M dash RQ. These two are opposite angle, so write the value here. Angle I plus angle, minus angle R1 plus angle E minus angle R2. Okay, simple application of geometry you have learned earlier also. So angle I plus angle E minus angle R1 minus angle R2. Clear? Now we have to take one more thing. What is that? That should be here. If I am taking a quadrilateral, for quadrilateral AQMR, AQMR, you see AQMR. So for this quadrilateral we can see that angle AQM, see properly, should be equal to angle ARM, that is equals to 90 degree. Why? Because you see we have drawn normal on the surface, I have already told. So as they are normal, so angle should be 90 degree. So this sum of these two angles, that is angle AQM plus angle ARM, that is equals to 180 degree. And we know the sum of angles for a quadrilateral equals to 360 degree. So that means if this two sum equal to 180 degree, so this two will be equal to 180 degree. That means angle A, that will plus angle M, A and M should be equals to 180 degree. This angle A, that means this one, it is known as angle of prism. We can mention it, it is angle of prism, and generally the angle of prism is denoted by A. Okay, and now we have to come here for another triangle. So it is little longer, but if you follow the steps, then we can able to understand it. So A plus M, that is equals to 180 degree, we have to pause it. So let's first give a number. It is equation number 1, and this is equation number 2 we have done. Now we are coming another triangle, triangle QRM, QRM. So for this triangle, see these are R1 and R2, and this is angle M. We all know that angle R1 plus angle R2 plus angle M, that is equals to 180 degree, because sum of three angles in a prism, that is 180 degree. Okay, so from here we can say that angle R1 plus angle R2, that is equals to 180 degree minus M. Clear? And from the equation 2 we can write, from equation 2, angle A equals to 180 degree minus M. So R1 plus R2 equals to 180 minus M. A equals to also 180 minus M. So if I have given a number 3 and it is 4, so from 3 and 4, so we'll write it here. So from 3 and 4 we can write that angle R1 plus R2 equals to angle A. And now if I put the value here, here we have written that from equation 1 we can write delta equals to how much? Angle I plus angle E minus angle R1 plus angle R2. So R1 plus R2 we can take it out. So instead of R1 plus R2 we can write A. So delta equals to I plus E minus angle E. That is the relation. So that will show you that how that angle of deviation depends on angle of incidence, angle of emergence and angle of prism. That is the relation. It's generally we have proved. Okay, but it is not like that you have to prove it, because this proof is not needed, it is not in your syllabus. But I have shown you to represent that how angle of incidence, angle of emergence and angle of the prism are related with the angle of deviation. So we can control the angle of deviation from here. Okay, so now we'll go for the another part, that is the factors on which angle of deviation depends. The factors on which angle of deviation depends, and you have to remember this equation because later we can able to use this equation. So I'm erasing this thing. Factors on which angle of deviation depends. First factor we have seen from the equation, that is angle of incidence. Okay. So if I change the angle of incidence, then the angle of deviation is also changed. But how? How does the angle of deviation change with the angle of incidence? So let's see by some diagrams. Now here I will show you some diagram. Now you might be asking, sir, how do you want to say that this type of diagrams only happen? Because see, we have done it by experiment. So in front of me it is not possible for you to show any experiment with prism because no prism is with me. If it is shown to you in your school, then it will be helpful, then you will understand that what we have theoretically learned, that is actually practically happened. So first I am taken one prism, and this is angle of incidence, angle of prism A, B and C. So when we are talking about prism, we generally take a equilateral triangle. Simple reason is that we have to discuss about equilateral prism. But apart from this also many more prisms are there that we have to discuss little later. Okay, so the angle of prism here for equilateral triangle, that should be 60 degree, but it is not like that. This is only one kind of prism. Apart from that no prism are there. It is not like that. Apart from this also many more prisms are there. So first I have to draw normal on the surface A, because by that normal only we can able to find out the angle of incidence. Now the light ray incidenting by this angle. So this angle, if we are not wrong, so that is near to 30 degree. Okay, so if you measure by your protractor, that should be around 30 degrees. So 30 or less than 30, not more than that. So if it will incident by this way, so from here it will deviate towards the normal by this path, and from here it will deviate in this direction. So if I want to find the angle of deviation here, you see, we will increase it and we will increase here. So that is our angle of deviation delta. So delta 1 we have taken. Okay, so for angle of incidence 30 degree. Now I have increased the angle of incidence little bit. Now you might be asking, sir, how do you understand the light ray go by this path? See, here I have bent it little bit towards the normal and here more towards the normal. So that's why the light ray seems to be like this. Next one, on the same prism, we have done one more experiment. That is normal. Okay, so it is little more than 30. So assume it is around 40, this path. Okay, so that is the path. If the light ray incident here, it will little bend towards the normal. Okay, and after that it will move away from the normal. Okay, so if I have shown you the path, so the light ray goes through this path, but due to the presence of the prism, it has come on this path. So that is the angle of deviation delta 2. So if I compare the deviation in these two cases, you see, as angle of incidence increases, the deviation decreases. See, initial angle delta 1 and delta 2, it is little lesser than delta 1. Okay, now we'll go for another diagram. See, each and every diagram is very important for you. For another diagram, now we will change angle of incidence mode. So here we have to draw the normal, and here the angle of incidence we have made this. That you see, exactly this is 90 degree and we just want to make it 45 degree. Okay, that is our target, to make it 45. And then the light ray will bend, and after that, when it is incident here, it will go by this path. Okay, now if I find the angle of deviation here, so that is your angle of deviation. Now you see your delta 3, it is much lesser than delta 2. So first case, the delta is more. If you increase the angle of incidence, then delta is less. More increase, then the delta is decreased much. Okay, now we have to see another angle of incidence. Now we have to increase the angle of incidence more, so like this. Okay, so here this one is almost 60 degree, almost 60 degree. Okay, and here it will deviate like this way. Okay, and now if I have drawn another normal here, it will travel by this path. So that is the original path, and that is the path we have gone. Now follow the changes. Initially, as we have increased the angle of incidence little bit, then we see the angle of deviation is decreased and decreased near about 45 degree. But as we have increased the angle more, then suddenly angle of deviation is increased. So that is the dependency of angle of incidence with the angle of deviation. So if this is also not clear, so if I have drawn a graph, I think it will be clear to you. We are just drawing a graph. In x-axis we are taking angle of incidence, and along y-axis we are taking angle of deviation. So if our angle of incidence is less, okay, very less, then my angle of deviation is along here. So we can take the value, it is around delta 1 here. If I increase angle of deviation, we have seen the if I increase the angle of incidence, so the angle of deviation is decreased. If I increase angle of incidence more, up to this region we have seen that angle of deviation is decreased. But after that, if we increase the angle of incidence, then we have seen suddenly the angle of deviation is increased. So assume here this value is delta 1, this is delta 2, this is delta 3, and this one is delta 4. So we can say that one certain angle of incidence, we have seen a very minimum angle of deviation. The angle of deviation is minimum. For an equilateral prism, if you see, so that will be around 45 degree. Around 45 degree. Okay, and there we will get the minimum angle of deviation for a certain angle of incidence. That certain angle of incidence is known as minimum deviation position, where delta m, it is denoted as minimum angle of deviation. Okay, so this is the dependency of angle of incidence with angle of deviation. And now practically whatever we have seen at minimum angle of deviation, in that case, that at delta m, angle of incidence should be equal to angle of emergence. That is practically proved. That is, if it is angle of incidence here, that is I, that should be the angle of incidence E, and here angle I should be equals to angle E. And one very important thing is there, the light, here we have to mention the light ray inside the prism. Inside the prism means this light ray that is passing inside the prism should be parallel to the base of triangle. That is this one, BC. This one and this one parallel to each other at angle of deviation, that is delta m. In generally, whenever we have done any experiment regarding this prism, we have to fix it at minimum deviation position. That means where that angle of incidence should be equal to angle of emergence, because prism is needed in many more experiments like spectrography, spectroscopy, and in that case you have to fix the prism at minimum angle, minimum deviation angle position. Okay, so if we have seen that is delta, we have seen that is angle I plus angle E minus angle A, and here if I find delta m, so angle I equals to angle E, so it is 2 of angle I minus angle A. That is the relation of minimum angle of deviation. Okay, so that diagrams along with the graph, so this graph I am telling you, it is very important. Okay, so all you have to practice this graph to show how the angle of deviation is changed with the angle of incidence. Okay, I think this concept is clear. That is the first factors on which angle of deviation depends. Okay, now coming to the second factor. So second factor, it is also experimentally proved. That is, the another factor is angle of prism. So angle of prism means if I am drawing an angle, this angle, that is known as angle of prism. Okay, so if I am talking about these factors, it is told if angle A is increased, then angle of deviation is also increased. If A is increased, then angle of deviation is increased. Practically, we can able to see that if it is a prism and the light ray travels through it by this path, if angle of prism increase means like this, that means the light have to cover a large distance through the prism because it will be more thicker, and that's why the deviation will be more. Though if we have seen the equation tells a different story, that here delta equals to I plus E minus A. So as per this equation, you might be thinking, sir, if A is increased, so the deviation should be decreased, it is minus. But we forget here angle of incidence and angle of emergence also plays a very important factor. Because if you increase the angle of emergence, because it covers a long path through the prism, that angle of emergence is very much increased than angle of incidence, and that's why the whole it will increase. And that's why if you take in A more also, your delta will be more. So in this case, this rule is not followed. Simple thing, if the angle of prism is increased, that angle of deviation is also increased, because the path of light ray is more through the prism. That is the second factor. Coming to the third factor, and that is also very much important. Number 3, refractive index of prism. And here this one also very much common. That is, if refractive index of prism is more, then deviation should be more. And that is a very common thing. More the refractive index means more the bending from its original path. It is a simple thing. More the refractive index means the optical density of that medium is more. So if optical density is more, then the speed of light is changed more also. And if the speed of light is changed more there, then the deviation will be more. So more the refractive index, more the deviation. Last, wavelength or the color of light. So that is also very common thing. If I have changed the wavelength, that means I'm changed the color of the light, then the speed of light is changed through a medium. So in air, the all colors of light moves with same speed, and that's why they can move combinedly as a white color. Okay, and that value is 3 into 10 to the power 8 meter per second, that we all know. But whenever it moves inside a medium, then for different color the speed is different. Why? Because we know the wave velocity, because light is a wave, so it will follow the wave velocity v equals to frequency into wavelength. So frequency is not changed whenever we have traveled from one medium to another medium, that I have discussed in the previous lecture, but the wavelength is changed. Okay, so it is clear, more wavelength, more speed in a medium, and more speed means less deviation. Simple thing, if I am talking about a car which is moving very fast through a road, so that if you see the path of the car, almost it is going by a straight line, because rest of the vehicles, they just give path to this car so that it can able to move fast. Okay, so more wavelength means more speed in a medium, so less deviation. Because if you move fast, so the deviation will be less. Assume you are going by a road, suddenly a very fast bike has come, so you will just come away from the road so that the bike can able to move fast, okay, through its own path, and there shouldn't be any sort of accident. But if you see a cycle is coming, then you will come away from the road? No. Then you thought then cycle will bend and it will move by changing its path. So simple thing, less wavelength, less speed in a medium, and more deviation. Okay, if I'm talking about that different colors, that is VIBGYOR, we all know the red has maximum wavelength and violets have minimum wavelength. So if you move a violet light through a prism, then its deviation will be more, and if you just pass a light red through the prism, then the deviation will be less, because the red has more wavelength, and that's why the speed of red is more, and that's why the deviation will be less. So that is the story about the refraction through prism. Now we will discuss some exercise drawing which are very much important, and then today's part will be over. So next thing we have to do, that is some important diagrams related prism. So here I have used the diagrams of your book only. I have taken with your book, and then how you have to draw the diagrams if it is given to you, that I have to show you. One very common diagram is this. So assume one prism is kept like this way. So if the light incident here, after refraction it will go by this path, and then it will go by this path. Assume on that path, if you have kept another prism in a reverse order, just like this. Okay. So if the light ray incident here, so it is the normal, so the light ray will bend like this, and here if you have drawn the normal, the light ray will go by this path. Okay, so that is the path of light ray if the two same prisms are kept just opposite to each other. Okay, one thing you have to see here, the incident light ray, if I have given the name D, E, F. So for drawing this diagram, you have to remember that AB should always be parallel with EF. And every time you have to use scale and to show the direction of light, you have to put the arrow sign. Okay, so that is one of the very common diagram has come. Okay, similarly, the next diagram, if it is given that it is in reverse order, it's like this, and if a light ray incident by this path, so simple thing, it will go here and then it will bend like this way, and after that it will bend here. Okay, remember here also, if it is A, B, C, D, E, so if I have missed any space, also E, and here it is A. Okay, so here also you have to remember that AB should be parallel with EA. Okay, that is the path of the light ray if the prism is kept in reverse order. Coming to the next diagram, that diagram is also given to your book, that one prism is given that is known as 90-degree prism. Okay, so it is clear that is 90-degree, and this angle is mentioned here, that is 60-degree. So it is clear this angle will be 30-degree because the sum of three angles should be 180-degree, and here the light ray is incidenting by this path. We all know if the light ray incidents on a surface just normally, that is by an angle of incidence 0. So you see in AB surface it is incidenting by an angle of incidence 0. So the light ray will travel in a straight path. Okay, so directly it will travel in a straight path. Now you see, if it moves in a straight path, so this angle will be 90-degree. That is not an angle of refraction. That is an angle which is made by the light ray with the plane. Okay, AB, that is 90-degree. And if it is 90-degree, it is 30-degree. So it should be 60-degree. We have to draw a normal here. So if it is 60, then it is 30. So the angle of incidence on the another surface, it is 30-degree. So it will move away. And that angle we cannot able to find out, theta. We have to take it is theta. Okay, that we cannot able to find out. We can able to find that as it is moving in a straight line, so the ray of light making an angle with the plane, that is 90-degree. This is 30-degree, and as it seems to be a prism, seems to be a triangle, so this angle will be 60-degree. And if I have drawn a normal, if it is 60, then this should be 30, and then it will move away from the normal with an angle theta. Now coming to another diagram. So assume this is a very thin prism whose angle of prism is 30-degree. Okay, and a light ray is incidenting on AB surface, that is also normally like this, and that angle is mentioned 90-degree. Clearly it is not angle of incidence, keep it in mind, it is the angle made by the light ray with the plane. Okay, and actual angle of incidence is 0-degree. So here also there will be no deviation, it will reach here. Okay, so if it is 90-degree, so this angle will also be 90-degree, and here if it is 90, this angle you can know that it is 60-degree. So if I have drawn a normal over this surface, so that will be 30-degree. Okay, because total, if I have drawn a normal, total is 90-degree. If it is 60, then it is 30. So how it is coming 60? Because sum of the angles of a triangle should be 180-degree, and then it will move away from the normal, and that angle we cannot able to find out. Okay, but which angle we can able to find out, that we have to draw. So another 90-degree prism is given here. It is 90, and this angle it is mentioned it is 45-degree. So if it is 45, this angle will also be 45. It is clear. Now the light incident here, this is the normal, and that angle is told it is 70-degree. So if it is 70 degree as per the diagram given to your book, so this angle with the normal, that is 20 degree, clear, and that is the normal given. So here the light ray will bend little bit like this towards the normal, and it will reach here, and that angle we cannot able to say, we cannot able to predict, and when it will reach in this point it will move away. Okay, and here we cannot able to draw or cannot able to mention what angle it should be. Okay, if I want to find it out, we need to know the refractive index, then sin I by sin R, that is equals to mu, and by that we can able to find this theta, but it is not needed. Okay, so you have to follow the path, you have to see if the light ray coming from rarer to denser, in which direction it will bend. Okay, so if you have drawn, these three diagrams are drawn in your book, so that's why I have drawn it. Okay, whenever we will practice the year paper, then we will get much more diagram like this, and we will practice that time. So for today this is enough. Thank you.